the pictures of yellow cake were awesome.
It looks delicious, doesn't it?
Hello and welcome to the HACKADAY podcast. I'm Elliot Williams.
And I'm Dan Maloney.
This is episode 268. RF burns, wireless charging sucks, and barnacles grow on Flaperons. This week in HACKADAY news, the big geek news this week was Voyager 1 resumes sending engineering updates to Earth.
Very pleased to hear that. I was seriously worried that Voyager had finally given up the ghost, but looks like there may be still some life left. Always hoping that the RTGs would be the final, just losing power would be the way that it goes, just sort of silently fade off. Not some catastrophic failure of early 1970s technology that's 40 million miles or 40 billion miles away from us or whatever it is.
There's this picture, I don't know, I clicked through the JPL website and there's a picture of the team celebrating when they first got their data back. And it's this really interesting mix of people who could have been college students at the time Voyager was put off to space and then, people who weren't born at that time either. They figured out where some of the memory was bad and they relocated code around it into space where it was good, right?
Yeah, that's my understanding, yeah.
Pretty cool. They just had to work around holes in the memory allocation, which software from that time when people used to know exactly in every memory location where the code resided. That's actually a big deal these days. Address space randomization, it's not the same.
Yeah, and I think the thing that gets me about this is like you said, is that the average age of the people in that room was probably somewhere in the 50s or 60s, and entire careers have come and gone on Voyager. We've lost so much of the information, and I got a dramatic example of that this week when I reached out to JPL for some information about Voyager's computers. I want to write an article about how the computers work. I think that's really fascinating how they got this thing, built with discrete CMOS chips in 1970 and sent it halfway across the galaxy. Well, maybe not that far. And there's this one paper I was trying to track down. I thought maybe JPL had it. And the public information officer said, no, we don't have it. I mentioned it to the engineers. They really want to see that because they need the information that's in there. Okay, well, if I get it, I'll give it to you. But I really thought that you guys would have it, sitting in a file folder someplace, or at least on microfilm or something. But nope, they don't have it, and I've got to get it for them. I've got to save Voyager.
You've seen that last scene in Raiders of the Lost Ark where they have that big warehouse, yeah. Right? And that's where their documentation is. I'm pretty sure of it.
Well, I know it's in a library in Kansas. So I know it's there. It's just that the library's closed right now and they won't give it to me. So once I get it, I'll be able to give it to them.
For real?
Yeah, for real.
A library in Wichita, Kansas.
Yeah, Wichita State University. It's somebody's private collection, and they were an engineer or scientist at JPL, or they did some work for NASA or something like that back in the day, and this guy had a copy of this paper that is basically describes the architecture description of the flight data subsystem on Voyager, and sitting in a file cabinet someplace, but it's behind construction tape at this point. I can't get to it. And I might have to go to Kansas.
Let no one say we don't do our research at HACKADAY.
That's Holy right. Cow. I'm trying.
Holy cow. Well, I hope you get it. And then I hope you give it to NASA, because that's a sweet end to the story.
Exactly.
Well, in totally not HACKADAY news, I'm actually a couple minutes late to recording the podcast because my mother just called me up and said something terrible happened. She just got hacked. And I'm like, oh, shit. And well, she at least may have gotten phished. She got one of those emails that says you have to make this outstanding payment or something. And she clicked on the link, and the link took her to some weird website with a phone number, and she called the phone number, and they started asking her questions about bank accounts, and oh dear. It has all the hallmarks. The guy on the phone, I guess, told her that she had been hacked, and he was going to trace the IP address, and it was some guy in Florida, and he gave the specific name of the guy who hacked her for $400 and something. And I'm like, this is the least plausible story I've ever heard. But but she bought it, and it doesn't look like they got any useful information out of her. But me saying the person you were talking to on the phone was the hacker was like, oh, I feel so dumb. You're right. And I'm like,
Yeah.
yeah, yeah. And she's like, why didn't anyone tell me this scam? And I'm like, yeah, your kids have failed you. So
Mea
so here I
culpa.
am. If you're a if you're a grandmother out there listening to this, let me just tell you, the people telling you've been hacked are the hackers, like 99% of the time.
But in my defense, when my mom got similarly phished, not too long ago, she's like, "Well, why didn't you warn me?" And it's like, "'Cause if I tried to warn you, you'd tell me I'm making fun of an old person who doesn't know computers, blah 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 blah." It's like, okay, well, I guess there was no win in this one, but at least in my case too, in her case, she didn't appear to do any permanent damage, and she realized it like right away. As soon as she hung up, she's like, "Oh, I should not have talked to that guy."
Yeah. Yeah. I mean, what worries me is that, I mean, she definitely clicked on some website controlled by the Fisher, right? So it could be,
Yeah.
it was a PayPal fraud, right? So they could have some cross-site scripting thing on PayPal that's like hoping to get credentials out of an open browser window or something. I mean, I have no idea what their angle is, or they just wanted to send her off to a website that gave them a phone number so that, they could get to a live friendly help personnel in to help
Yeah.
take her bank account details or something. But I think we'll see how this turns out. I'll keep you all updated next week on the story of my mom getting fished. But yeah, unbelievable. And speaking of fishing, let's do What's That Sound?
Oh, hey.
This is a journey into sound.
What's that sound?
This is one that you have a chance of getting because Al Williams picked it.
Okay.
So if you can get it, you can thank Al, and if you can't blame me.
Oh, that's WWV.
So close. Almost.
Yeah, well, okay. Hold on a second then.
That's so close up.
No, it's not changing. So it's not WWV because that changes every 30 seconds.
I tell you, that is about the rightest answer. I'm looking over all the answers right now, and that's about the rightest we've got.
Okay. How far off am I?
Different continent.
Oh, that's the German one.
DCF 77. You
DCF
win.
77. That's it. Okay.
I have to give it to you.
I
That's
needed help though. I needed help.
Yeah, well, how would you guess? No, I would have accepted time transmission signal on that one. So WWV is, yeah, it's a radio time signal broadcast.
There you go.
Did anyone, I'm going to look through the answers real quick and see if anyone actually said DCF. We got Sputnik, a whole bunch.
Kind of does sound like Sputnik. It was faster though. Sputnik was a little beep 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 beep.
We got radio time signal, radio time signal, radio controlled clock signal, which I guess is technically also true. White noise backup alarm. I don't know what that means. Weather balloon transmission from HAB RS41. Wow, that's very specific.
Strangely specific.
But probably not right. Weather
But incorrect.
facts, that's a good one. Low scan TV, weather scan, that's a good guess too. Ooh, these are great ideas. I'm going to totally use these for later.
Yeah.
Sounds like a satellite beep, but not like Sputnik might be pulsar. Oh, might be a pulsar. Yeah. I'm going to call this one. I think we got 5 right answers. WWV, I'll take as one. Time signal, I'll take as one. And we're good. This was a tough one. I'll give you that. And I blame Al Williams, but it was a good one. We got 27 answers and 5 of them right, which means I can roll a normal 6-sided die. Here goes. 3. Radio time signal. Congratulations, Medic 456. I'll get in touch with you and get you a HACKADAY podcast t-shirt. Rest of you, tune in next week. We'll play this game again, and you'll have your chance to guess. Sputnik Mackenzie is a very good nickname for this one. All right, I'd like to start off the hacks this week with an informational, maybe even controversial piece from Shahram Mokhtari of iFixit. It's how wireless charging works and why it is terrible. And this is basically a look at the power losses you get from using wireless inductive charging versus using regular old cable charging. And the target here, I guess, is a cell phone. I think it's, a fairly modern iPhone, one that wants to charge at like 20 watts or something. So it's moving some pretty beefy current around to get the job done. And that, of course, is the problem, basically. What I thought was really interesting here is they start off with a baseline, that is, of how efficient a wired charger is. And I was shocked at how bad the numbers were until they kind of broke it down a little bit. They're saying there's a 35% loss with the cabled charging solution. And what they're doing is they're putting the wall wart charger into a power meter in the wall and measuring how much power comes out of your wall and then comparing that to the capacity of the battery. And so they've got a 12.7 watt hour battery, and they discover that it takes 18.25 watt hours to charge. And most of that loss isn't in the wire at all, of course. Most of that loss is in the AC to DC converter, the rectifier and down converter that's in the wall wart itself. And that to me is just shocking. And they claim they're using a fancy new gallium nitride one. And just with that, they're losing 35%. I mean, some of it's got to be in charging loss, but at least I thought at moderate speeds, the charging loss into lithium battery chemistries was very low, like, 5% or something. So 35% was shocking to me. And so that's already a bad baseline, loading your phone through wires. But it gets significantly worse the second you introduce a wireless charger into it. And, he gets into the various different topologies and kind of the second generation of wireless chargers like the Apple MagSafe and the Qi 2 standard, which have an internal magnet which self-centers the inductive rings around each other, is actually a really clever system. But even so, it ends up with a 60% loss, basically, compared to the 35% loss on the other system, which is to say it takes 23 watts to charge a 13-watt battery. Let's see. Oh, and it gets even worse because then he picks up a normal Amazon Basics charger, which doesn't have the magnetic centering facility, and takes 34 watts to charge the 13-watt battery. So that's a real bummer. But his point, and I think this is totally valid, is that when you have a wireless charger, it's also on the rest of the time, and it's looking for your device to be put on top of it. And this always being active actually draws kind of another 3 or 4 watts over the course of a day. And there's some other losses with slow charging and activity overnight. Well, if you just leave your phone on the thing overnight, that ramp it up as well. Long story short, it looks like it takes about twice as much energy to charge your battery as you think it should if you use a wireless charger. I'm still shocked by how bad the wired charger is. But again, all this is because if you think about it, it's got this chain where it has to take the power coming out of your wall, AC, it has to do to low voltage DC. It then has to chop this to get high frequency, like, AC, to send across the gap between the two coils. And then the other side gets this high frequency AC that then it has to turn back into DC, and it probably also has to do some voltage, like a DC to DC voltage correction before it finally gets to stick it into the battery. And so there is kind of all of this loss along the way.
I'm kind of two minds on this. I mean, I've become painfully aware of like phantom loads ever since I put my shack my workshop / office that I spend almost all of my time in. I put that on my solar system. It's completely off grid. It's powered by the sun now. As a result, I'm very careful with what I turn on in here, and I don't want to put the big lights on overhead, because then all of a sudden I'll go up from 117 watts that I'm drawing right now to whatever, something, and that just eats into your battery faster. So I'm keenly aware of the amount of current that even the few little wall warts that I have plugged in represent. It's amazing that they actually draw that much. But on the other hand, I kind of don't care, because I kind of need my phone to charge. And the the charging, the USB port, for some reason, it won't charge over the USB port anymore. So I did get a wireless charger, and I've got it on my nightstand. I set my phone on it at night. It charges and it's fine. And, when I get up in the morning, it's charged and I'm all good. Could that be more efficient? Absolutely. Should it be? Probably, but it's not. So sorry.
Yeah.
I got to move on to something else. I can't worry about everything. So it's too bad that it can't be more efficient. But I guess that's where we are.
If you look at it versus the wired, so if wired takes 18 watts to charge the battery, and a good wireless takes kind of 30 and a bad wireless takes kind of 58, you're still looking at a differential of kind of 30 or 40 watt hours per day. That does add up, and that's it's real power, but at the same time 30 watt hours is how many hairdryer minutes? Not very many. How many?
No, not many at all.
How many slices of toast is that really? It's. But I guess once it aggregates up, once you aggregate this around the world's billions of cell phones, this loss is actually pretty significant. Of course, there aren't billions of wireless chargers. You gotta hope, but still, it's really, really shocking. I'm still blown away by how inefficient it is. Like charging a battery should be, especially a lithium battery. Should be like 90-something%. Like that should be easy.
Now, what the question is, was it back when linear power supplies were pretty much all we had?
Yeah.
What was it worse or was it better?
Oh, it was worse. It was significantly worse, right? I mean, because they got hot, right?
Yeah, that's true.
Like you could
they
feel
get
the
hot.
wall wart in the wall, and it was warm. Like that's a bad sign, right?
True. The noise floor was lower though.
True. Speaking of heat, though, that's the other point that Sharam makes here, is that all of the losses going on, most of them are on the phone side because the coils have to be thinner there. The coils in the base can be big and thick, and so made out of chunky wire. The ones in your phone have to be thin because, cell phone, and they're right next to the battery. And so they also threw a temperature probe in there. Of course, the waste heat gets dumped into the battery, and that's not good either. You don't want to charge lithium-ion batteries hot. I don't know. I mean, they get temperatures up to like 40 degrees, which is hot, 40 degrees C, which is hot, and kind of keep it under 30 is a good rule. So, it does get a little bit hot, but I don't think that's going to be what ruins your cell phone straight away anyway. On the other hand, given that all cell phones have easily replaceable batteries, none of this matters. You just buy a new cell phone battery and put it in, right? You don't have to throw away your $600 phone just because the battery's dead. Don't be silly. That would be stupid.
First up for me, reverse engineering the Quansheng hardware. So the new hotness in amateur radio, and just for, people who like to play with radios in general, whether they're licensed or not, is the Quansheng UV-K5. If you're familiar with the Baofeng radio that is everywhere, you can get it for $25. It does UHF and VHF ham frequencies, but you can also use it to, you're not supposed to, it's kind of illegal to use it for family radio service and MURS service, but you can use it. So it's become quite ubiquitous, and I mean, you see it as props in TV shows and movies. It's all over the place. But so that was the sort of the standard in cheap hackable radios, although there weren't a lot of hacks for the Baofeng radios. But the Quansheng radio has changed that quite a bit because first people got into the firmware of the radio and then, did all kinds of cool things. We saw some hacks on HACKADAY that were like playing Tetris, I think was one of them. People adding meters to it and waterfall displays and all kinds of neat stuff. But now people are getting into the hardware in a way that I never really remember the Baofengs being hacked for their hardware, other than just taking them apart completely and reuse sort of in a caseless sort of way. Quanshengs really lend themselves to hardware hacking, but you need a roadmap if you're going to do something like that. And so this is what this is all about. This is Mental Detector plus colleagues Ludwig and someone else, Manuel, got together, sort of collaborated on an effort to take this thing completely apart. Yeah, it's basically one PCB, not that many parts. It's all pretty accessible and approachable. It's all surface mount. The process was basically taking everything off the board, piece by piece, testing each component to figure out what its values are. Obviously, there's components like integrated circuits and stuff like that. Figure out what from the markings what they do, get data sheets together for everything. For the components that couldn't be tested with a component tester, they sort of figured things out with a nano VNA to see like what the values would be for inductors or for capacitors that were unmarked. Did all this work, got a bare naked PC board. Now, bear in mind this is again a $20-$30 radio, so taking it apart destructively and reverse engineering it that way there's not a huge barrier to that. You could probably take apart a couple of these before you started really feeling like you were doing some damage. Bare PC board, documented both sides of the PC board. It ended up being a 4-layer board, so they wanted to find out what was going on the inner 2 layers. Lapped down the board with some sandpaper to get down to that lower layer. Photographed those, then did a stack of photographs of all the layers, so with and without components, so that you could kind of X-ray vision the thing. And from there, worked backwards and got a schematic. Everything's in KiCad. PCB design has been recreated. You could basically rebuild this radio from scratch. I don't know why you would when you spend $25 and have it done for you already, but you could potentially do that. And it does open up huge doors for whatever you want to do. If you don't like the filters on the radio, then you could design new filters. If you if you want to interface in different ways and do new and unusual things, all right out there for you to take advantage of. So hats off to the team for some great work. And hopefully it'll result in some really cool hacks.
I just love seeing this sort of, documentation and hacking effort, and just the brutal sanding to get at the 2 center layers of the 4-layer PC board. I love that. I wonder if I can go find that talk. There was a great talk by Joe Grand at DEF CON, and then there was another one at Chaos Communication Congress. I can't remember who gave that one. I will have to go find those for you and throw them in the links. Some great talks about various methods to reverse engineer PCBs when you kind of destructively, but how to get into the insides if you absolutely need to. The short answer is, of course, the lowest tech solution actually does work. You can really just like glue it to a rock, take some wet sandpaper and a flat surface and just go at it until you get there.
Yeah.
And as long as you're careful, you're going to win. Like it's just epoxy. You just have to sand the fiberglass layer away. Keep it wet. Don't breathe in the dust. You're probably good. Go slow.
Yeah, there was a photo of the board in process of being lapped down, and you could definitely see that there was a flatness problem or a lack of flatness problem. The board was rubbed away more at the edges than it was in the middle, or maybe it was the other way around. I couldn't really tell. But you could definitely see that someone's hands were on the board while that was rubbing, and it was causing pressure. So you could probably come up with someone came up with a lapping machine. I think it was Electron Update. Many years ago is when I first started writing for HACKADAY. I'll try to find that one. But he came up with a lapping machine for chips, and I think it used a CD. No, not a CD. It was a hard drive platter, because that would be very, very flat, and coat that with abrasive, and then, be able to apply very even pressure to the chip under examination, and then just lap away the epoxy or even get down into the silicon and go through layers of the silicon. So yeah, stuff like that could probably be used for something like this. But whatever they did a great job, and it's really cool to see the internal layout of the board. I mean, I'm just looking at the collection of little bitty inductors up near the top of the board in the RF section. It's kind of cool because you can see that they were careful to turn them 90 degrees from each other so that there would be no coupling for magnetic coupling between the coils. Pretty much all of them are oriented correctly. It's actually a pretty well made radio. It looks pretty solid. I mean, there's some complaints about some things. The filtering is always a problem with these little radios. There's only so much filtering you can do. So I think that's probably one point where people are going to try some hack on this thing is improving the filtering. But hey, neat stuff.
My next hack comes from Priscilla. This is kind of more of a PSA than a hack, but it's a really neat story. Your smart TV does 4K surround sound and denial of service. And this starts off with the craziest bug finding exercise. Her PC isn't able, it's a Windows PC, isn't able to open the display settings. She's like, I don't know what's wrong with this NVIDIA software. It's probably just buggy. Just updated to Windows 11. And then other things in the operating system stop working. She does a music studio, so there's some MIDI input-output stuff that isn't working. Finally, Task Manager stops working right. Then some streaming things go wrong. All sorts of various things in her desktop computer start breaking. And what's going on here? If you're a Linux person like me, you're saying, Windows, of course it doesn't work. Windows computers eventually self-destruct, right? But she goes digging into this and it just, reinstalling drivers and the whole thing, right? And every time it'll bring some relief, but then in a few days it starts going bad again. Heavy, heavy internet searching leads her to the solution, which is absolutely insane. It is her smart TV. And what it turns out to be doing is trying to reconnect to the network using different device IDs. And something in the Windows operating system is seeing all these new devices on the network and caching them. And so eventually the TV is just throwing out bogus device ID after bogus device ID. And her Windows computer is like, oh, there's a new TV on the network. Oh, there's a new TV on the network. Oh, there's a new TV on the network. And it's logging all of these. And eventually it just kind of overflows its brain and it can't check through all of them. And so then the part of the Windows networking stack that checks through all of these devices that don't exist out there on the network is what's hanging everything else. And so some kind of bizarro Windows dependency chain of all of the parts that depend on the network are sitting there waiting for this networking stack to come back, but it has to check through 1 million device IDs on the local home network, and that's what's hosing the computer. It is absolutely insane. Why it is that, Taskmaster uses the device host thing to look at all the devices on the network, nobody knows. That's what's killing the Task Manager. Bluetooth, of course, also uses the same device discovery procedure. So it's going to hose all over Bluetooth. Network discovery, file explorer, same, right? So, I mean, the moral of the story is computers and operating systems are so damn complex that it can look like you have a problem with your computer, and it's not. It's a crazy other device on your home network that's doing something that makes your operating system go into tilt. Unbelievable. And the fact that she was able to find this flaw at all is pretty amazing. This, of course, suggests to me that you could take a little ESP32 and just start creating, quote, devices with various UUIDs on a network and just leave that in some enemy's house and slowly poison all their Windows computers. Not that I would ever do such a thing,
nasty.
But it does suggest this. And they'll never find it. Never figure that out.
But and that's exactly my point here is, I mean, imagine this, we'll go back to our moms. Our moms call us my computer's not working. Are you going to start looking at, are you going to trace it all the way back to the TV? Hats off to Priscilla for following the rabbit so far down the rabbit hole and actually figuring it out. I mean, I'll keep it in my back pocket for someday. I doubt I would have figured this out. I probably would have just given up at some point and, re-imaged everything and just said, hey, okay, here you go.
That's what you do, of course, and then that works. But then after enough UUIDs have accumulated in its list,
It's going to happen
it
again.
starts again. And so, like, and you could buy a new laptop. You could be like, oh man, this computer is so old. It must just be slow, because this is what Windows people
Yep.
do, right? They're like, it's the computer's old. That must be why it's not working, neglecting the fact that it used to work 10 years ago. Why doesn't it work now? And the answer is, of course, he no shade, Windows users, no shade.
Yeah, no.
But here in this case, the answer is that something in the network is actively swamping it, and that's just too funny, but also completely undetectable. And like how you would find this bug, I do not know. Oh, it kind of reminds me of the time when I DOS'd my entire house. Our home automation system relies heavily on these 433 megahertz on-off wall sockets, right? And I have a little radio that transmits to it, and it was connected to an ESP that then bridges it over from the other parts of the network. Long story short, this thing sends out the command codes to these 433 megahertz radio receiver plugs, and they turn on and off. If something in your code crashes and your sender leaves the pin that's responsible for sending to the data floating, then random values are continually going out to this radio, and it's just broadcasting hash, completely jamming the 433 megahertz spectrum for everything. And your wife finds out she can't type on her wireless keyboard. You can't turn the room lights on and off. I don't even know if my neighbors could turn their lights on and off anymore, but
Whoopsies.
Yeah, so there was a good week where that was down, and I was probably, I don't know how much I was jamming, but that was one of those trouble searching problems where at first we just thought one of the switches was bad, right? Or like this light switch doesn't work anymore. It must be the wall plug. You're stuck with this, like, where you find the problem, right? And that's her problem here, is that Windows is screwing up. And so the problem must be in the computer. And you never think that it's going to be somewhere else.
Well, I mean, it really is the logical conclusion. And there's so, especially when it's a Windows machine, right? I mean, there's so much that can go wrong. So it kind of makes sense to look there.
I guess in the end, it kind of was, right? I mean,
True.
It should be robust to millions of UUIDs on your local network.
Yeah.
Right?
I guess the real lesson here is your TV shouldn't be talking to your network. So,
but that is the other lesson, is that TV is doing what? Why is it re-enumerating every 5 minutes? Like, that's crazy already. Like,
why does it need to do that? Yeah.
It's definitely the TV that's crazy here. Microsoft engineers, you could take some solace in the fact that this TV is rogue, but your operating system has to be robust to rogue TVs.
I guess now, yeah.
These days.
These days. All right, going old school, more old school for me. Radio frequency burns, flying a kite in you. This one comes from Grant's Past TV Repair, who kind of takes one for the team here in demonstrating how you can get an RF burn from nothing but an AM radio. In the neighborhood is a local AM broadcaster. They've got a tower on 1270 kilohertz. And point of this whole thing is just to demonstrate the power that even a low power AM radio transmitter puts out. He built basically what amounts to a half wavelength antenna. Does the calculations, figures out that that's 368 feet 6 inches, and can't really figure out how to get that antenna in anything approaching a vertical position. Comes up with the idea of flying a kite and basically using the antenna lead as the kite string. Rolls out 368 feet 6 inches of wire, and sort of in a Ben Franklin moment, takes a finger and touches it toward the end of the wire, and wouldn't you know it, a little spark comes out. And the funny part of the video is him saying, "Hey, look at the smoke coming off of my finger. That proves that you can get an RF burn." Like, well, yeah, it proves a lot of things. I guess. It seems like it'd be very uncomfortable. His hands look pretty gnarly. I mean, maybe he's got calluses and stuff like that. I don't know. But for me, that would be, I just wouldn't want to do that. I don't like that idea, but he does it. He takes one for the team and shows that it's possible to get an RF burn just from the energy from an antenna that's, I think he said it was just a couple miles away. It wasn't very far away. He also does a little trick where he just lays the antenna out on the ground, and it's still capturing enough current basically that he can light a little LED that's grounded to a fence post. So there's a lot going on here. Most of the comments tended toward the kite safety, and the that you should never fly a kite using a wire as a kite line. You should have the regular Dacron line and then hang the antenna from the kite is safer for some reason, or there needs to be a breakaway so that if the kite string breaks, the antenna is not dragging across like high tension lines or something like that and hurt someone. So, I mean, I guess there's safety rules for flying kites, I guess. I mean, I thought it was just as simple as don't fly a kite near a power line and don't do a Ben Franklin and fly a kite in a thunderstorm. But
Right.
I guess there's more to it than that. And Grant's past TV repair discovered what the limits are.
Things I learned today. Yeah, I mean, when you say it, it totally makes sense to use something non-conductive for the line that's actually connected to the kite.
Yeah.
Like I buy it when you say it, but I probably would have done the same stupid thing. And I mean, the other thing I learned is that even your fingers have magic smoke in them. Like, who knew?
Yeah, smells like chicken. Someone in the comments did link to the Jeff and Joe Geerling Engineering channel on YouTube, where they purposely took a hot dog and grounded it on a long insulated stick, and put a nail through it, and then a lead going to ground, and then touched it to the actual antenna structure of one of the AM stations that Joe Geerling is the engineer for, and cooked it, actually more like ablated it. It just this vaporized the hot dog, and while it's vaporizing, you can hear the programming that's going on. So the hot dog acted as a as a rectifier and I guess a speaker too at the same time. And just disappeared, and just in order to give you an idea of what you really shouldn't be doing with an AM radio tower.
At some power levels, a hot dog is a crystal radio.
It's true. Or your finger. I mean, I suppose that the last thing you'll hear is the whatever the programming is on the radio. But
Too dark. Yeah, that's amazing. Yeah, I mean, how many watts is in a good AM station? 100,000 watts?
I think the
50,000
limit, the
watts?
clear channel limit, is 50,000 in the United States.
That should cook a hot dog.
Oh yeah, it'll cook plenty.
All right, my last hack this week is flute now included on list of human interface devices. This is a sweet hack by Joran to do pitch detection and turn it into mouse movements. So he's got a microcontroller, it's an RP2040, also enumerates as a mouse to the computer it's plugged into. And so when it hears one pitch, it moves slowly over to the right, and when it hears another, it moves slowly to the left. There's a pitch for click. And we have a video of Joran demonstrating this thing. And I'll be the first to say this is a recorder and not a flute. But this is also the absolutely worst way to control a cursor on your screen. It's hilarious. There's like a 20-second segment at the end of the video where he moves the mouse across the screen up to a icon and then he clicks it. But it takes him so long that he has to do like 3 breaths to get the mouse across the screen just in the horizontal direction. And then he has to go left, right at least once or twice to get it nicely centered. And so he's playing these different notes, doo-dee-doo-dee-doo, to try to get it to wiggle into place. Absolutely fantastic. He has this fantasy picture of him sitting in a hammock on a tropical island with his laptop and him on a recorder controlling it around. It's lovely. This is not a practical device at all, but it's a super interesting look into and very nice demonstration of pitch detection. And so if you want to do any kind of pitch detection for a small microcontroller project, you should absolutely check this out. In particular, I was thinking, pitch detection, he's going to be using Fourier, or if he's a little bit sophisticated, he'll be using the Goertzel algorithm. But no, I'm wrong. He's using the yin pitch detection algorithm, which is out of a research paper in 2003. that he has linked. If you're ever stuck doing pitch detection, this probably looks like a good way to do it. I actually love pitch detection as a problem, and so I went digging into it. The long and the short of it is it's kind of a variant on the auto correlation idea. So the idea is if you took the sound sample you have and you shift it over by a bit, it would maximally match itself at kind of when you shifted it over by exactly the fundamental wavelength, right? The wavelength of the fundamental frequency. You can imagine shifting it over till each peak overlays on each other peak. And that's kind of the maximum correlation strategy. This is even better than that. And what it's doing is it's taking the difference between 2 points in time and it's squaring them and summing them. So if you have the wavelength exactly right, the points all cancel out exactly and you get a 0. Whereas if they are shifted off of each other so you don't have the pitch right, then you get strikingly, sum of squaredly different from 0 answers. And it turns out to be significantly more accurate and not even super hard to implement. So it's a great strategy for doing pitch detection that I didn't know about until today.
The first thing I thought of when I saw this one in the tips line was the scene from Willy Wonka, the one with Gene Wilder, not one of the other ones,
right?
Where he pulls out a little flute and bloop, and he play and the Oompa Loompas just appear. So I maybe it's something like that, but then I watched the video and I'm like, oh, okay, no, it's a little bit more complicated than just summoning the Oompa Loompas. And I'm also glad that Brian, who wrote this up, put a link into the trombone champ guy, because that guy's been doing some great work with trombone-based HIDs.
The last tidbit from this, of course, is that floating point on the RP2040 is slow. It doesn't have a floating point unit. And so he ends up learning something about fixed point math, which if you're ever in the same situation and you need to do like DSP type stuff on a microcontroller that doesn't have floating point natively, this is fixed point is the term you need to Google and go down that rabbit hole and learn about it. It's pretty good. He takes his code down from requiring 88,000 microseconds down to 8 microseconds. So it's a factor of whatever that is. It's 5 orders of magnitude. That's the factor of 10,000. That's ridiculous. So just from a little bit of coding work, he makes this thing work blindingly fast with tons of leftover CPU time, where before it was barely able to function. So good hack, good bit of programming, cool pitch detection algorithm, and a completely absurd and ridiculous application of USB human interface devices.
Okay, my last pick today is relatively universal ROM programmer makes retro tech hacking accessible. This comes to us by way of Anders Nielsen, who you may recognize the name. He did a hack chat recently, first of all. He also has been working on 6502-based microcontrollers. Why? Why not? If you can use a CPU from, 30, 40 years ago, then why not? Let's do that. I actually have one of them sitting on my desk here. He very kindly sent me one, and I've been meaning to get to it, but a lot of projects are in the way. One of the problems I have, though, is the one that he identifies in this project, that when it's time to actually program this thing, you need an EPROM programmer. And that's maybe a barrier to entry for people who don't want to spend 80, 90, $100 or more for a good ROM programmer that they can plug in with a USB port just to program one ROM. So he started toying around with ideas on how to make that whole process cheaper. Breadboarded a simple programmer, got that up and running. We followed along with the with his process here as he's been working on this. Wrote a couple articles on this, and now he's got a final form of this that basically is a shield that goes on top of his 65 Ueno board that now will program pretty much any EPROM that you put in it. The high voltage ones, the more modern ones, it's chip size doesn't really matter if you put the right socket in it. The whole thing would only cost about $9 or $10 in parts, exclusive of the ZIF socket, which you can still get for pretty cheap on eBay. It's a good tool for programming And it does open the door for anybody who is maybe put off by some of the more expensive bits of the retro computing hobby. I'm looking forward to building one as soon as I can. I think he's done a really good job here in bringing this whole thing together. And the whole project of 6502 and assembly language programming really is very interesting. It's kind of that lost youth sort of thing. This is the way we used to have to do it, even if maybe you're a little too young to actually have lived through that part of it. I mean, I didn't get to participate in the first round of real 8-bit, putting it in with the switches and watching the blinky lights kind of computing. So this is kind of a way to relive that or live that the first time, I guess. He's making it all relatively affordable and as universal as possible. And I think that's a pretty good result.
These old school EPROMs, like I had to program one of the old UV erasable ones for an old synthesizer. It needed a ROM upgrade and I ended up doing it. And I have the world's most horrible device built to do it. I'll have to get a picture and put it up here. I basically just connected all the wires with jumper cables, right? So it's this huge mess. It's a horrible rat's nest of ZIF socket plus DuPont cables, but it gets the job done. These things aren't entirely trivial to do, and half the battle's just having the ZIF socket. So yeah, definitely what Dan said, go out and buy some. They're cheap if you order them from AliExpress or eBay or whatever. Definitely worth having a few on hand. But the rest of this is like the thing that's really difficult these days about EPROMs, at least the UV ones, is that you have to have a high voltage source, where high is like 6 volts, 9 volts, 12 volts. It's not like millions, but it's definitely not 5 volts either. And so you have to be able to program them at 1 voltage so that the bits stay in there. And that part is a little bit tricky. I think this board does it. It actually says it has a variable high voltage power supply up to 30 volts. So that's pretty cool. And that means this probably is fairly universal. Like, he's not kidding with the title. This thing actually probably will do them all. And that's really convenient. And, I'll show you my rat's nest of DuPont cables. And if that doesn't make you want to make one of these, I don't know what will.
Yeah, he put a lot of work into the voltages and not only, not only finding a way to do it, but also finding the most economical way to do it. And he was very clear that early on in this process, he's like, no, we're not going to do the easy way, because the easy way would be a part that's $1 versus the hard way, which is a part that costs 6 cents. So he's doing that value engineering, very early in the process, and the results show when you can build it for $9-10. It's a success.
And just anecdotally, he had these up on Tindy, and they all sold out within the first day. He totally got HACKADAY on this one. You all bought them all out. He says he's going to make some more. My first quick hack this week is the performance impact of C's final keyword for optimization by Benjamin Somerton. There is in C++ a keyword final which says that this class isn't going to be subderived later, and it could possibly theoretically give you performance gains. Benjamin doesn't trust it. He tests it out, and with a bunch of different compilers on a bunch of different architectures. And the answer is sometimes it's a performance gain, sometimes it's not, sometimes it's slower, sometimes it's faster. I think the story here is, A, question your assumptions about what compilers do and what they don't do. And B, if you care about performance, you absolutely have to just make the test cases and go out and measure it. And he does that here, so thanks. Next up, implantable battery charges itself. This is a bit of futuristic medical engineering tech from a group of Chinese researchers. I couldn't figure out which university they're associated with. It's basically a battery where the missing ingredient is oxygen, and you can implant it in human tissue. And when your blood gets around it, it provides it with enough oxygen to keep running. I've seen The Matrix. I know where this ends. Next up, Chip Mystery, the case of the purloined pin, is another public service announcement by Gili Yankovic. There is no SCK, no clock pin on the CH32V003 when it's in SOP16 footprint. And he was completely surprised to see that, of the usual 3 SPI lines, it's got a clock line and then it's got an incoming and an outgoing. The clock line was just totally missing and it's not there. And then so he looks back at the data sheet and lo and behold, it's just not there. It's, in the higher pin count packages, of course, it's broken out. But when they reduced it to this super tiny one, that was one of the pins that fell on the cutting room floor. He was bitten by this. It's not a bug, however. This happens a lot. And I've used a bunch of chips from like ST where in the 100 pin count package, they have all of these fantastic peripherals. And those are the headline ones that, of course, they put on the top of the data sheet. And when you look at the 24 pin version or the 32 pin version, like half of those had to get cut away. And sad but true, if you're going to pick a reduced pin count version of a microcontroller, make sure it's got all the features you want. And last up, the Muse Permanent Magnet Stellarator Fusion Reaction with off-the-shelf parts. The Stellarator is a weird fusion reactor design and may be the one that is easiest to build, where, with fusion reactors, easy is in big scare quotes, right? But this one is a room-sized, desktop-sized even, fusion reactor you could make yourself with normal permanent magnets, not those crazy hyper expensive superconducting super magnets. Original paper was from the early 2000s by the director of Germany's Wendelstein 7X, which is their giant superconducting stellarator design. And this is a paper of a rebuild of it by TM Chen and al. So go check it out. Maybe you don't think you need to build a fusion reactor yourself, but when you read this paper, who knows? Some of you will be inspired. If anyone builds a fusion reactor and blows up a city, HACKADAY is not responsible.
But we do want to know about it. My first quick hack is bad experiences with a cheap wind turbine. This comes to us from the project list. And come on, take a look at this thing. It's just a goofy looking anemometer. They were hoping that it would be actually something they could produce power with. However, it doesn't seem to actually do that. Maybe no surprise, this comes from Vivor, the apparent news source of all things that don't quite meet expectations. It cost about 100 euros and it's supposed to be able to produce 600 watts. And as far as they could tell, it produces no watts. So watch out for weird wind turbines that really are just basically a goofy anemometer. Next up, we're back with the Gearling boys. AM radio broadcast uses phaser to let 8 towers spray one big signal. This is another one of their great inside looks at broadcast engineering. Joe is the father of Jeff. Jeff, you probably know a little bit better from his Raspberry Pi stuff on Jeff Gearling's channel. His father is the broadcast engineer in the family, and they tour around and take a look at all the cool stuff that's inside some of the transmitters. Today, it's a look at the phasers with an OR instead of a, shoot your phaser. The idea of this piece of equipment is that it controls the signal going to an array of antennas and shapes the beam so that they stay in compliance with their license agreement. And there's some really cool technology inside of these cabinets. And last up is Ancient Cable Modem reveals its RF secrets. This one comes from Jared Boone, who managed to get his hands on a modem from the Naboo network, which was a very small cable internet, well, I guess it sort of predates internet, cable data network that was launched in Ottawa, Canada in the 1980s, early 1980s. This modem is a treasure trove of quality parts and construction techniques you just don't see anymore. It goes into the analog section and works on the digital section as well to some degree. Everything in there is built with discrete chips. There's no microprocessors. There's no even large scale integration. And there's a lot of analog goodness. It's kind of cool how he developed a whole block diagram and almost a working schematic of this thing, just based on observation, poking around a little bit with a signal generator, and looking at the results on an oscilloscope. It's part 1 of 2, so we're looking forward to the next one to see how he can actually put this thing to use.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I picked Tom Nardi's SuperCon 2023 Alex Lind Explores MCUs in InfoSec. And half the reason I picked this because this is a celebration and we've gotten the processed video from our video folks and we're going to get to publish them for you and we're super excited about that. So stay tuned. We'll be trying to get at least one talk out every week from the Design Lab stage. And we were able to stream the main stage, but not Design Lab. So these are all new videos for those of you who weren't at SuperCon. So yeah, Alex Lind is exploring MCUs in InfoSec. Basically what this means is he is playing around with ESP8266s and then ESP32s later on to do kind of security pen testing network foolery. And this is, I think it's because I was watching this video that it gave me the evil ideas of repeating that problem that the TV had, repeating that problem that Priscilla's TV had on purpose to be a bad person. Anyway, security talks always get me in the right/wrong frame of mind for these sort of hacks. He's just got a bunch of really sweet small devices here that are basically the consequence of saying, well, what if a computer that could get on the network were cheap enough and small enough that you could hide it anywhere, and it was cheap enough that you could essentially just throw it away, right? You could afford to leave it wherever and see what happens. What could you learn? And that's kind of interesting. One of his first devices is just an ESP8266 wedged into like a USB power converter and put in the wall. And it notifies him whenever a certain MAC address comes in the area. And he was using it for entirely non-nefarious purposes to alert him when his dad was in his dad's office so he could go visit him. But the point of this is this could be used for all sorts of sketchy tracking or useful tracking. And I think that's kind of a neat application in the sense that it's just a few lines of code. It's a dead simple thing to make. But it's actually a cool functionality. Like if you're tracking someone's phone's MAC address, you can use it for, am I home? Should I have my home automation system do something? You know, it's not necessarily nefarious or InfoSec purposes, although you could. Other things he did, the one I particularly liked was his warshipping experiments where he would put basically a Wi-Fi data logger in the form of an ESP32 and a battery and an SD card in a package and then ship it to a hypothetical company. I don't think he actually implemented this one. And it sits there in their shipping department for a day or two, collecting all sorts of network information. And because he's put the name of a non-existent worker on the thing, it eventually gets returned to him. And so the idea is it sits in their network for a few days until it gets eventually returned directly back to you, the dirty hacker. And I kind of like that too. I think that's a really sweet, it's just a sweet idea. And last but not least, a lot of his trackers and stuff use DNS tunneling, and that's something I haven't seen used in a long time. And frankly, I wonder if it still works, if a lot of Wi-Fi networks, open Wi-Fis, or, you know, the captive portals have gotten wise to this trick. But if they haven't, and I think they haven't because Alex is talking about using it here, you should check out the whole DNS tunneling idea. We've written it up a number of times on Hackaday. This is a write-up actually of mine of a project of Casey Buds where he made a car tracking GPS unit that connects to all the Wi-Fis it finds along the way and sends a DNS request to a server that you control. This DNS request is usually forwarded by most Wi-Fi access points and contains the data you want to send. I think some small number of bytes, 16 bytes or something.
And it's talks like these that make me sort of regret not going into InfoSec. I mean, it really wasn't a thing back when, I was trying to figure out where I was going with my life. Having it come along and watching all of the red teaming stuff and like you said, warshipping and all that stuff. This is just my mix of, of deviousness and and technical cleverness and all the things that really, sort of make me tick. Plus the idea that you could, be a pen tester and actually have someone pay you to break into their whatever, and you basically get a get out of jail free card, but still have the thrill of being able to break into somebody's stuff. Then I mean that would be awesome. I would love that. Missed chance, but hey, that's the way it goes.
Yeah, I don't know if I'd do it as a career, but I do kind of like the hobby hacking aspect of it too. And
That's what makes one a criminal. If you don't do it as a career, no, I'm a hobby pen tester. You see.
no. If you're just looking at your own home, you're in good
know.
shape. A man's home is his pen testing castle.
Yes, exactly.
That's right. Do not do this without permission. No, I just love the feeling you get out of this talk because all the devices are so simple and so cheap and, so clever. And it's just all in this kind of spirit of, hey, here's a thing. I'm just going to go figure this out. Hey, here's a thing. I'm going to go have a look at that. Hey, I wonder if I could XYZ. And that kind of exploratory spirit is, I think, really cool, even if you're not interested in exploring the security of, a site that you're getting paid to look at.
Okay, my pick this week is Lewin Day's The Hunt for MH370 Goes On with Barnacles as a lead. It's been, almost 10 or more than 10 years since Malaysia Airlines Flight 370 just up and disappeared. It was supposed to be going from Kuala Lumpur to Beijing. It never even made it close to that. It started going almost the complete opposite direction before it fell off radar, and nobody knows where it finally ended up in the ocean. Big mystery. How could this possibly happen? Well, I mean, I think it's pretty obvious it could happen because it's a big ocean and a little airplane. But generally, we get some sort of clues when a plane disappears. We get something. And there have been these tantalizing little tidbits of information from GPS information, from reflected radio signals, all kinds of these ephemeral little bits of information that suggest where it could have been and when it was there and maybe what happened, but no real hard evidence until stuff started washing up on the shores of various islands and countries ringing the Indian Ocean where the plane was believed to go down. One such piece of debris was a flaperon, which I guess is sort of a combination of a flap and an aileron on the, I think this is an Airbus that went down. And that washed up on Reunion Island in July of 2015. It was covered with barnacles. So that kind of gave forensic investigators an idea of maybe we could figure out where this thing started its journey from the crash site. The flaperon actually was verified as coming from MH370. They knew they had a piece of debris. They had it covered with barnacles. They figured, well, maybe we can take a look at the barnacles and figure out where they've been. And it turns out to be possible, but not necessarily as helpful in this case as they were hoping for. The barnacle in question is not your ordinary barnacle like you'd see on a piling at the beach or something like that. This is a tremendously large barnacle that can get scary big. These things are pedunculated, so they got this long stalk that they attach themselves to objects, and then at the end of this stalk, which can go up to 80 centimeters long, and that's kind of creepy if you ask me, you've got the actual barnacle proper, the I think they call that the capitulum, so that's got all of the barnacle parts in it, so the abdomen for the digestive system and the little things that do the filter feeding, that's all in this capitulum. Barnacles grow by excreting shell material, and they do that in response to conditions that are around them, such as temperature and salinity, and I would imagine sunlight plays a role to some degree. But basically, they form rings that kind of provide a record, kind of like looking at tree rings and inferring climate data from the width of tree rings and stuff like that. You could do the same thing with barnacles. In this particular case, they were looking at isotope ratios, oxygen 18 versus oxygen 16, which are related to sea surface temperature that the barnacles experience. You are likely to find them attached to, flotsam, things that are just floating around, like Flaperons from lost airliners. But you also find them attached to things like sea turtles and crocodiles. Anything that's slow moving enough and kind of floats near the surface, if they have the proper surface that's it's available for the little eggs to attach to, or I guess they're nymphs, they'll land there and they'll grow up and exploit that ecological niche. What they wanted to see in this particular study is if the oxygen isotope ratios actually told them anything about where the plane crashed. The information is a little bit contradictory. There's some inconsistencies between the age of the oldest barnacles they found on the wreckage versus how long it must have been in the water, given they knew, within a few hours when the plane crashed. And they also know that the barnacles only inhabit things that are floating near the surface. So it's not like it could have been below the surface in 8,000 meters of water or something like that, and then broke off from something and floated to the surface. There was some inconsistencies there that didn't make any sense. The other thing that didn't make a lot of sense was they took a model of the Flaperon piece. They built basically a replica of this piece, did some float tests on it, and found that it always floated in a particular way so that part of it was out of the water. They couldn't get it to do anything else but that. That was a little mysterious because the part that's out of the water was the part that the barnacles were on the one that they found on the beach. So that doesn't make a lot of sense because there'd be no way for the barnacles to make a living if they're on this exposed part of the wreckage. So that's a little weird. Maybe the actual Flaperon that washed up on the beach, maybe that was flooded differently. Different compartments had water in it compared to the replica that they built. There's a little bit of hand waving there that they're not quite sure, how the barnacles managed to get on the part that was up above the waterline. But all of this is really fascinating. They did manage to make a map of possible paths through the Indian Ocean from sea surface temperatures encoded basically in the shells of these barnacles, but none of it really gives anybody, look here, it's down there, information. It's all suggestive and interesting, and it may be a lead, but there's no real firm answers yet. Still, it's kind of a neat use of biology for solving crimes. Things like that are fascinating use of biology, and the time to shine for people who specialize in weird things like seed pods and barnacles, and they can actually their area of interest that seems so narrow, and so why would anybody bother studying barnacles? Well, this is a use for them.
As a website where like 90% of our readers are all knowers of specific weird information.
Yeah, exactly.
I love seeing this sort of thing happen, right? This is the specific, barnacle ecology version of that. But, we run into this one in spades in electronics applications all the time. And yeah, I agree with you, though. I do love seeing it. There was a documentary about these kind of forensics investigators, and they'd practice decaying bodies. They'd left decaying bodies in the ground and would come and look back at them every once in a while to see how the insects had eaten them up over time and stuff like that. This whole thing where they recreate a model Flaperon and see how it floats is exactly that sort of flavor to it, right? Like, is really it's very weird esoteric knowledge, and like you say, it does eventually have an application sometimes, and I love the idea. So you've got all this data, you've got historical ocean current data, you've got historical ocean temperature data, and then you've got a kind of a time series of temperatures encoded in the barnacles. Surely that would let you decode the path, you might think. And I do like the idea. I think that's really sweet. And, like you say, I'm kind of bummed that they came up with a whole bunch of multiple paths, and then B, it doesn't really narrow anything down in the end. That's anticlimactic, because a priori, you might think you could really do this.
Even not doing this work is important. And in the paper, they kind of enumerate some reasons why this would matter. This barnacle knowledge would matter. Like I mentioned before, the sea turtles, sometimes they are floating on the surface, and they'll gather barnacles, but they won't typically gather those unless they're sick. Because then if they're sick, if they've got some other disease or some kind of disease or something like that, they'll just sort of sit at the surface and not move their flippers much. So their flippers will tend to accumulate these barnacles only in the sick animals. And that's interesting. I mean, that's something that you could maybe use to track diseases in sea turtles, which probably is something that's useful to keeping populations like that alive and unendangered, to the extent that they are unendangered. I think a lot of sea turtles are having a lot of problems. Interesting stuff that might actually have some practical real world applications, aside from hopefully helping to find a crashed airliner.
That wraps it up for this week's Hackaday podcast. Thanks very much for listening. To find the links or leave us comments, head on over to hackaday.com/podcast. And as always, send us tips at hackaday.com. And until next week,
keep on hacking.
Definitely record these stories because it's funny. Are you ready?
Ready. Wow, that's a long one this time.
You are so far away.
Yikes.
It gives us some sympathy for Voyager, though.
Okay, my first quick pick, like we're playing the lottery.
It's loading slow because it's so long ago. Barnacle anatomy.